Today's webinar is from Forum Analytics. I went to a conference this past summer and they were one of the vendors there. I got to talking with the people and the technology was really cool. So I asked them if they would be kind enough to put on a presentation for us, and they gladly offered. So thank you, Forum. As you can see, we have Nisa and Kastub on the line. Kastub is going to get the presentation, so let's go ahead and get started. Go ahead, it's up. You're all set.
All right, awesome. Nisa, before I share my screen, anything from your side, or we're good to go?
Yeah, I think we're good to go. I appreciate everyone making time, especially during a hectic time of year. And yeah, any and all questions, don't hesitate to throw them in the chat. We can even answer as need be.
Cool. I'm sharing my screen. Can I just get quick confirmation you can see the screen?
Yep.
Yeah. So we didn't have like an official title, but the motto that we are building our application and all the technology is build better together. And I'll talk about, it's just not about we creating a technology, but if it really needs to work for all of us, we need to work better together with other technology partners like Bentley and Trimble and others. And also we need to make sure we are working closely with you guys, the engineers, the owners. And when all of us come together, that's where the infrastructure can be really state of the art. So that's the constant theme through what we are doing. And let's talk about the traditional methods of investigating utilities. So if you are, and I'll talk about design tickets, dig tickets, kind of similar situation, but because we are right now focused so much on the conceptual design, preliminary design, early design phases, we are trying to look at this workflow. What is it? What is the current status quo? What's required for you to get utility data early on when you are doing the design or concept study? So current workflow is you submit an 811 ticket, you get list of utility owners, you contact them. Sometimes they respond, sometimes they not. What you get as a response could be a hand-drawn sketch, and this is actually a real ticket that was submitted through the system, right? So then you need to get that sketch, you need to digitize it. Sometimes you'll get road marks, and then you need to create all of that, stitch it together, put it in a GIS system and CAD system, and that's the broken process. And plus, on top of it, if there are road marks, you have to go and visit the site because you need to capture the road mark, then convert it digital. So somehow, some way, this process is, I don't think so it's efficient. It will take you a couple of weeks to, in some situation, few months to get all that data together. And it requires, if you look at the current process, it's like people are converting from GIS system, their internal GIS system, sometimes to hand sketches or road mark. And then again, you guys are going and collecting that and converting it back to CAD and GIS. So it's a broken system. And that's where we want to fundamentally change how a design is, or in the design phase, how utility data is accessed, how quickly that the utility data is available to you. And instead of in the early concept phase, instead of worrying about accuracy, hey, is this line exactly at this location? Instead of worrying about that exact accuracy, we are focusing on comprehensiveness of the data, meaning within a band of 4 to 5 feet, we know a line exists over here. Here are the evidences based on which the line, we can say with confidence that the line exists. So let's look at how we are doing it. So we have built something called AI conflation engine. What that AI conflation engine allows us to do, and it took us substantial time, like 3 years to build a conflation engine. So at a state level, let's say state of Texas or California or Georgia, Florida, what we start with is collection of millions of data points. These data points are GIS layers, PDFs, permits, anything that we can find in public domain. We're not accessing any private repository. We're not reaching out to utility owners. but we are just searching the internet and we are collecting, in, let's say, state of Texas, 10 million plus data points. These data points then are synthesized through our AI conflation engine. So there's a lot of noise. So step number one is rank all of these data points which are relevant from a utility side, which are not relevant, and then reduce that millions of data points to a few thousand. So that is a whole filtering process that we go through. Once there are a few thousands, what we do is that's where we involve humans, because just using AI at that point of time is cost prohibitive. You can keep on further filtering down, but it becomes super complicated to further filter down. So we have GIS analysts. They go through at a state level few thousand data points. So we finish a full state mapping within 6 weeks, 4 to 6 weeks, and out of those thousand data points, this is how the output looks like. So this is a water network in Dallas downtown area. These are potential reliable lines from the public records. But as you can see, this data coming from public record is not good enough because you have duplicates, you have coordinate system errors. So water lines are literally all over the road. So if you just purely consider public record as it is, you will have conflicting information. One GIS layer will say, oh, the line is on the left side of the road. Another PDF will say, oh, no, it's not on the left, it's in the middle. This map kind of represents it. So this is where, again, we introduce the AI and clean that map using a bunch of techniques. So we remove duplicates, we do coordinate system normalization, there's data normalization, so on and so forth. So now from that complex multiple lines going across the road, we have a list of limited lines that we can work with. But we just don't stop over here. We add on top of it evidences that we have from our imagery science, the on-surface utility objects such as pedestal, hydrants, manholes, valves, so on and so forth. And now recently, we also introduced ability to identify road marks, the spray paints on the ground from our street level imagery. And the thing that we have cracked in this specific aspect is not only identifying an object from an image, that's relatively easy part, but the triangulation, placing that object on the map and doing it at scale. So this is how the road marks are detected. And now what we are working on in parts of US, it's already there. We can start generating a fully new line, which was never present in any public record. So we could generate it from scratch. And the entire thing I explained doesn't work at a small level, but it works at a state level. So we can start processing Texas, California, Florida, so on and so forth. And it's not a stale processing. It's not one-time processing. Each state, we revisit the data, go through again that millions of data points, so on and so forth, about 6 to 8 weeks. So each state constantly gets updated little by little as the data gets added. That's the conflation engine we have built. And with that said, let's jump on to the product. And I think it will be better explained when you look at the product itself. So here's how our product looks like. We have 18 states pre-mapped, and we have ambition of pre-mapping the entire US sometime by end of next year. So let's see how that plan goes, but we have major states pre-mapped. Yellow dots that you see over here are the projects that I have access to. So what I can do now, I can go to any of my pre-mapped state. Let's say back to that Dallas example, right? I can go in here and I can start drawing a polygon like this and create a project. Or if I have like a linear project, I can go and create a linear road drawing and give like whatever width you have, so 200 feet width for this road. Or another option is I can upload KMZ, KML, or shapefile. So I can go in here. I already have pre-mapped KMZ, which is in adjacent area where we were drawing, and I can name this project. Let's say this is our conceptual design, and this is, let's say, for a road project. And you can click on utility map. So within matter of seconds, what will happen is your utility information will start streaming in. There are a few enhancements that we will go through, and I'll show you how those enhancements look like. So you got these utility lines, and there are few more triggers that you could do. So this is an object detection. Object detection is about identifying the utility objects on the map and also on the roadmap. So if I click this for this 1 square mile of a project, it will take us about an hour to finish the object detection. But after object detection and road marks are finished, this is how the finished product looks like. So you know what I'm going to do is I'm going to turn off all the noise, and let's zoom into a specific area, and let's explore what's happening over here for natural gas. So if we look at this specific area, I've only turned on the gas line. And if I click on the gas line, I can see it is from Atmos Energy as an owner. We got the sector, all of that. So that's coming from public record. Now, if I turn on our gas meters, you can see there's a meter that we have identified on the side of the building. So I can click on a meter, I can go to a street level imagery, and here's that meter that I can visually verify. So there's definitely a meter over here, there's a line, but there are no records of transverse lines connecting those two. So let's also turn on our street or road marks. So here now we have captured road marks. I can click on a road mark. I can go to that specific view. I can validate, yes, the road mark exists. Here's the marking. It's going to that meter. And now by combining all three evidences, meaning lines that are coming from public record, meters that we have identified based on our image science, and plus road mark, I can confidently say as an engineer, hey, here's a lateral that is present. Although it's not present in public record, I'm fairly confident there's something over here. So if I'm doing any sorts of road modification, or if I'm, let's say, installing a new utility line in this area, I know there's a lateral I need to be aware of. So that's what we have created, fully automated. So if I now zoom out and if I go to analytics on that particular project, in this particular area, we have 8,000 plus objects that are detected, and that's not including the road marks. So if I zoom in, I can start seeing the road marks. And many times, again, the conversation goes to the accuracy part. Hey, are you guys completely replacing the survey needs, or are you guys replacing SUE? Not at all. Rather, it's exactly opposite. We are giving you a comprehensive picture of where utilities are and the evidences that why we think utility exists over here, but we are not an engineering company. So we are not stamping any of these drawings. We are not saying, go take this and start excavating. Rather, what we are saying is, here's a comprehensive view based on which you can decide what level of SUE you want to go for, what level of surveys or potholing you want to go for this project. And here are the evidences based on which we can be pretty sure, hey, this is what we have identified. And in terms of accuracy, that question also comes into play. It depends, right? Because in this particular situation, if I look at the mark and the line, they are pretty much aligned. So I can go and verify the mark. Yes, mark exists over here, and the line is pretty much aligned from the public record on the mark. But let's look at this particular situation where the line is off by 3 feet. Now, if you ask me as an engineer, is the mark right or the line right? I don't know. That's where further investigation is needed. So that's the product we have built, instant access to utility data, not only the public data sources, but the imagery science, which will give you a lot more confidence of what utilities exist within a particular region. We also have information about the owners, so I can go and explore. I can see the list of utility owners which are operating in this specific area. You can download this list. We also have more analytics. For an example, we provide parcel information. So you could go and turn on the parcel, click on a particular parcel, see who's the owner, what is the land value, parcel value, so on and so forth. We also identify a bunch of crossings. So if you're doing undergrounding work and you want to identify every place where electric and gas lines are crossing, because those are your problematic spots for permitting, here you have a quick report of what could be potentially problematic. And all of this analysis is also available to you as a dashboard. So here's a dashboard where we are summarizing the risk on the utilities. So here's an example where for the particular project, there are lines which are exceeding 20 inch. Most of the times they are problematic. There's also a substation within the boundary that we have drawn. So you have ability to go and investigate, okay, where is that substation and figure out you are not doing modifications around it. And bunch of graphs and charts, again, with parcel, with right-of-way information, and some of the large diameter pipelines. Now, we will have questions towards the end, so please wait for the end part to have your questions. But in terms of large diameters, I actually want to talk about a use case where 4M was used in one of the TxDOT project, and I'll talk about this particular project. So one of our engineering partners used 4M for understanding of risk on a new bridge project that TxDOT wanted to execute. If you go and look at the risk, there are large diameter of wastewater and stormwater lines which are over here. If we scroll down and if we say, okay, show me the lines, looks like there's a 120-inch wastewater line. If I go over here and just say show only, here's a line that we have identified. Again, this is coming from public record, right? So compilation of public record, we identify 120-inch line. So what happened on this project? The foundation was proposed over here. In conceptual design, the design firm missed to get this particular 120-inch sewage line from the public record for whatever reason. And then with our other engineering partner was brought onto this project, they use our software to identify all the lines, and that's where they discovered the foundation is right at this spot, proposed at this spot on top of this 120-inch line. We also provided information about the parcels, and this turned out to be a historic parcel, and there was no possibility of acquiring any easement in the specific parcel. So because of these early identification of issues on that project, TxDOT actually went in and did a very detailed investigation on this particular line, and I'll show you the screenshot of that later in the presentation. What they found out is this particular line is, if I'm not wrong, 54 feet beneath the ground. It is I think more than 120-inch, 140-inch diameter line, and it's partially pressurized sewage line. Imagine if foundation was installed or foundation was proposed over here, and TxDOT, maybe by the time they go to sea level A, they would have discovered, oh, there is a sewage line which was missed in early conceptual design. The whole project comes to halt. That's why identification of this data as comprehensive as possible early on in the concept phase, you cannot put price to that, right? Missing a line like this and running into a trouble, meaning you're losing millions of dollars. And imagine if this line was never detected, which could be a very remote scenario, but it's possible because it wasn't identified at all, then any foundation close to this would have caused a tremendous amount of disaster for city of Houston. So this is an actual real life example. Using our technology, we could identify potential conflicts very early on in the project and save headache for our engineering partners and a bunch of money for our owners. So that's a real use case that I'm personally extremely proud of. Okay, going back to a couple of other features that we have, what you could do is also perform routing analysis using our product. So we can go and either draw routes within the product. So I can start drawing a route like this, or I could upload an existing route, let's say from here. So I have pre-created a couple of routes. There's a line that goes in this direction, the dotted line that's over here, and another line that goes in that direction. And I can kick off initial analysis. Let's say this is a fiber optic line that I'm interested in. It's a 3-inch line. It requires 15 feet easement. And then material-wise, let's just choose something like some sort of plastic material and run the analysis. So what's going to happen, we're going to identify all the conflicts within for each of the line. So here for line 1, 36 conflicts, 44 conflicts. We will identify what types of, when I say conflicts, these are crossings, so existing lines crossings, how your line is traversing through different types of parcels for easement, how much of it is within the right of way, outside the right of way, and we will show a recommendation from our side saying this line is optimum. So out of 2 lines that are drawn, this path is more optimum than going in this direction for the reasons that we will explain over here. So that's our routing analysis. It's still under development, it's still in beta, but yeah, you could do the initial concept planning using this. And I think for this group, I'm assuming a lot of you work with DOT projects on the road design as your Bentley user group. What you could do is you could create potential conflict matrix again in the conceptual stage. So what you could do is you could upload a bunch of polygons. So you could export, let's say, from open roads polygons as a KML, KMZ, or a shapefile, and then upload it over here. I'm just going to draw a couple of polygons just to show you the feature. So let's say this is like a turning lane. So I'm categorizing that as a road 6 feet deep. And then let's say I have another modification going on this one, which is a sidewalk. So this one, let's name it sidewalk, another 6 feet, and continue. So you could have multiple meshes defined over here, or you could just upload it as I was explaining before. You can provide the depth bands, and you can just create a conflict matrix. So again, this is not a final conflict matrix, but this is something you start with. This is your initial Monday.com type of a list where you will see what type of conflict it is, the description of conflict, the utility type, whether it's within the right of way, outside the right of way. And now we are working closely with many DOTs. So the next evolution of this particular feature will be share this particular conflict with a contact with Windstream in this situation, right? Share this with Windstream and have Windstream come to the platform, come to 4M, apply the comments, apply the callouts, upload PDFs. So this becomes your initial coordination for your utility conflict matrix, and it will evolve from there. Future plans for this is even to have this list exportable to different technology partners. Bentley will be definitely one. Trimble could be another one where this list can go into Bentley's farm services as to-do list, and then you could resolve it over here. So that's on our transportation planning. And last part, talking about integration, what we have built is ability to stream the data from our tool into other products, GIS system and CAD system. So we have developed something called WFS, Web Feature Service. So using Web Feature Service, you could, so this is the URL that you will get from our app, and you could integrate that with any GIS or CAD system. So here I'm giving a demo on a ArcGIS system, but you could do the same with Civil 3D or MicroStation using the WFS integration that's available there. So here I've added the layers for all the folders, or sorry, lines for all the folders. Let me add another layer. I might not have copied that URL, but this is fine. We can just go and style this. So let me style it, and we'll go and zoom in and look into the details. We just increase the width so we can see it better. All right. So here are the lines that are getting streamed from 4M directly into the GIS. You could see not only the lines are streamed, but there's also like the metadata that we have captured is also getting streamed. So you'll know the diameter, the owner, the type of material. When we have captured that from public record, all of this is available. Again, having this either in open roads or MicroStation or even for your site planning, open site will be extremely valuable. So you can get this data directly from 4M into your CAD solution. And when you are planning and designing transportation project or whatever type of project you are interested in, you have much better understanding at that early planning and early concept phase. And as you get more data from later surveys, either it's a SU report or a survey report, you can keep on updating, either replace the layer or keep on updating those layers in your CAD tool. Okay, the last thing I wanted to quickly touch base on is our ability to download CAD files. So there are other downloads. So here you can download KMZ, KML. This is like a list of utility owners download, but you can also download a CAD file. As of now, we have DXF and DWG, but we are working on DGN CAD download. So this is not what I wanted to show, but here's that output. So you get DWG and DXF as of now, and we are working on creating a DGN output. So we'll be utilizing MicroStation SDK and creating that output. So that was the product demonstration. In terms of just where the industry is going, there's a lot of thought leadership coming from DOTs. So here's an example where TxDOT have put out their artificial intelligence strategic plan starting this year, where 2025 is almost ending now, but going into 2026 and 2027. And as you can see over here, some of the use cases are really about using AI to identify utility mapping and conflicts, using AI to make sure the utility risks are identified. So this is not we creating our marketing content, but it's actually a DOT who is putting out the strategic plan, which completely fits into how our product is defined and where we want to go. This is our product roadmap. So a lot of these points I've already shown and discussed with you. We are working with multiple DOTs, so our collaboration platform and enterprise grade level security, the admin management reporting, all of those table stakes for enterprise customers, we do have it and we'll constantly keep on improving it. We did talk about the workflows, road planning or transportation planning, route planning. There's also another one that we are working on, which is 811 tickets. So that workflow is you will be able to auto submit 811 tickets from our platform itself. And we will track the response for those tickets, and you will get a comparison that 811 responded to a ticket with, let's say, 10 owners, and here's a list of owners on 4M. So our platform just becomes the centralized platform where all of this data, instead of putting it into disconnected system, it becomes a central system where things happen. And in terms of integration, I already demonstrated the web feature service, but what the part that I'm personally excited about, by the way, I worked at Bentley for 15 years, so the company is very dear to me. So we will be working on a Bentley connector, where in the next slide, I'll show you the potential outcome of that connector, but it's literally converting the 2D lines into 3D diagram and putting that into iTwin experience or Bentley Infrastructure Cloud. Then there are other functionalities that we will just keep on developing, more stuff on AI, more stuff on data, so on and so forth. But before I close this presentation, I just wanted to reiterate that story. So this is the screenshot. This is where the engineering partner that we are working with took our data, converted that to 3D using their internal scripts. This is where we will have a connector to fully automate that workflow. But here is then 120-inch line that they have identified. And then here was the proposed foundation. Then the story coming full circle when I was attending TechStart right-of-way conference week before Thanksgiving, where TechStart actually presented with one of their vendors who can send equip or instruments within the pipeline. So because of we flagged this line, what they did is they went out and hired another technology firm who sent an actual instrument through this pipe. And they actually identified, yes, line exists. It's not at the exact location what we shown on the map. It's few feet off, but it's still problematic for foundation. So they have to figure out where to move this foundation. And it all happened. This investigation happened because this was highlighted as a potential conflict. Now they will figure out what are the mitigations. There are a few things that they are doing in this area, and maybe there is a solution. But we avoided a potential heartache for everyone across the system. So again, that's our motto. We want to make sure we build better together, partnering with all of you, partnering with other technology firms like Bentley, and at the end of the day, deliver a better infrastructure project. So with that, we can open for question and answers from audience.
That's awesome, Christo. Thank you very much. Let's try this for the first time ever. Let's see if I don't screw it up. But if you have a question, let's try raising a hand and I'll set your audio on. But I got a couple questions in the meantime. Can you explain how this AI technology works? I mean, if you're going out and this going to GIS databases, everything else, some of these might be a pay portal, some might need login. So how do you bypass all that and download all the information?
So anything that is behind a firewall, we are not touching it, right? But surprisingly, there is tremendous amount of information available just in public portal. For an example, many of the private lines, anytime a DOT bid goes out, their PDF captures, because they have done the survey, it captures everything within the right of way. So our technology really shines when it is for the right of way data. Now, again, the limitations are if you have a private campus, then we won't be able to provide the same quality of data what we can in the right of way, because the public information is mostly available within the right of way. So we're not trying to break any firewalls, go behind the firewalls and trying to capture it, rather learn from the public documents, augment that with the imagery science. That plays a very important role in how we create our map, and then produce this data.
Okay. And can you tell us how, what 18 states are mapped and ready to go?
Yeah, sure. Nisa, can you copy that list over here? I mean, all of this will be available over here, but it's starting from Texas was the first one. So Texas, California, Florida, Georgia, Colorado, Utah, Minnesota, New York, and I just named eight, but the list goes on and on. And you could find the list over here: Washington, Pennsylvania. So you could Idaho. So you could see like March, we launched Idaho, then. I think May we launched Pennsylvania and it just keeps going on and on and on.
I think they told me at the conference that Michigan is mapped.
Yes.
Okay. And the biggest question here is what's the cost for this?
Yeah, contact NISA. You want to know more. What the way we price is based on project segments. So you could see for this particular project, depending on the area, we charge project segments. But for more information on subscription, contact NISA for that. But it's
Okay,
nowhere
Nisa.
compared to SUE cost, right? It's like fraction of SUE cost.
Okay, Nisa, can you while we're still on put your contact information in the Q&A? And I see we have one question here. Can you see that, Kastu
I,
or
Uh,
Nisa?
Give me a second. My chat window has disappeared.
yeah, Cassie, if I can read it to you.
Yeah.
So this is from Jeff. He said you mentioned publicly available data, but that's not typically as-built drawings, municipal GIS, private utilities, etc. Specifically, as-built drawings seem as though they would be the most valuable. Is that something you're looking at adding?
Yeah. So let me just clarify. When I say public available data, it is not behind a firewall, right? So the scraping engine that we have built, it accesses all, let's say, as-built drawing or anything that's for bid that a DOT has put out, which is not behind their firewall, but it's not easily searchable. Our AI engine goes and accesses that. So we do stumble on as-built drawings sometimes. Now, being said that, our engagement with DOTs right now is exactly going in that direction. So what DOTs are saying is, hey, this is great. This is all you captured based on data you had access to, but you didn't get any access to data that's behind the firewall. Here, let us give you a few as-builts, and then can you start modifying your data based on the as-built? So that's exactly where the engagement is going with DOTs and with few engineering firms too.
Um, and just to reiterate or stress this point, this is basically for preliminary design. You're still going to need to go out and do your final utility search. So
100%. Yeah. Thanks for reiterating that. I couldn't stress that more, right? By no means we are here to replace SUE. If anything, we have like a SUE cost estimation report, and we are encouraging, okay, for this particular project, if you had to go for SUE level B, here's the cost, here's the justification of the cost. So we're kind of providing the initial data to start discovering more and going into depth, so on and so forth. So yeah, this is not something to be used for final design, but for conceptual design, for early design, pre-planning phase, this is where we really shine.
okay, I don't see any hands up or any more questions, but to piggyback on what Jeff was asking, I can see maybe not with the smaller local agencies, but with the DOTs, you think something could be worked out with the DOT to gather all their as-built to populate this stuff?
Yeah, but the challenge is it all depends on how they want to share the data. Not all DOTs are willing to say that, hey, let's open our as-builts and let's make this data public. But some DOTs are thinking in that direction. Hey, we have this 30-year-old archive, a lot of scanned PDFs and stuff like that. And we want to share this data for betterment of infrastructure. So we are seeing both out in the market. So in some situation, yes, the data shared by DOT will end up available to everyone who's using the platform. In some situation, it will be only DOT specific.
Okay. Well, I do not see any more questions.
And Chuck, I don't see a chat capability, and I'm not able to do Q&A, but I can work with you on a follow-up email that includes our information as well as a screenshot of all the states that we have the foundation data in.
Okay, if anybody's on a call or interested in the contact information, you can send me an email and I'll forward that to you. We're also going to put this video up on our YouTube page, and I'll send that email out too when that's ready. I don't think 4M has any problems with that, do you? For us to publish this video?
No,
Okay.
I think you're good.
Okay. All right. Well, with that, thanks 4M. I think it's an awesome program. I can see a lot of good uses for it. So I'm going to show this to my higher ups in my company and see if it's something that we can use. But especially if you're working like in a Dallas or downtown Detroit area, it's nothing but spaghetti. So I can see a big advantage to this. So thanks again for taking the time out and to host this for our group. And hopefully you'll get some customers after this.
Yeah.
So with that, we'll close. Anything else, Nisa or Cousteau?
No, thank you so much. Appreciate the invite.
Yeah, thanks for the opportunity. It was great.
All right. Well, thank you. Have a good
Thanks,
holiday. All right. We'll see you. Bye.